My title to the first talk this evening is the big problems with the Big Bang. And I'm going to be talking about cosmology, which is a science coming from the name, coming from two Greek words, cosmos, meaning world, and logos, meaning literally word, or more generally, the study of. And so we generalize this to be the study of the structure of the universe. Now, we generally today think of this as the big picture, the everything in the universe, but there are actually cosmologies which are smaller subsets of all that. I'm not going to talk about that this evening. And one thing we have to realize was that we are always encumbered by our own preconceptions and understanding of our lifetimes and our culture and our times. And that can be a very dangerous thing. You got to be aware of that bias we have. As a 21st century astronomer, I try to make sense out of the world, and I try to interpret that in terms of what I know from scripture. But I have a difficult time many times because of the biases I have. Now, the ancient Greeks, we always tie our science back to them. And they had a cosmology like this. You can see there's a spherical earth on the inside. By the time of Aristotle, the ancient Greeks understood the earth was a globe. And it's surrounded by a hard crystalline transparent thing, the celestial sphere, we can call it. And you'll notice little yellow dots on there. Those are stars. Those stars are different ones in the sky. This is a model I had at the university where I used to teach. Took a photograph of one of the models. We actually have about a dozen of these at the Answers in Genesis we use in workshops. It's a very useful tool to describe some of the aspects of the sky, but no one's really thought this is how the world works for a number of centuries. But for about 2,000 years, this was the cosmology, going all the way back to the ancient Greeks. This thing would spin around the earth each day, or the earth would spin on its axis each day, it doesn't matter. And it could really explain quite a bit of what we would see. Now, today we think the stars are much farther away than would be allowed on this necessarily, and also they're at various distances, not all at the same radius, as you can see on the globe there. And the Greeks used a word to describe this. This word was stereoma. And stereoma is a word meaning hard or firm. And that's going to be very important here in just a moment here. Now, as I cautioned a moment ago, we are always formed and shaped by the world around us. We can't help but do that. And it's a constant concern for Christians to be thinking biblically. And we need to sort through all the things we know or think we know and test them and see if they are consistent with Scripture. That's a tricky maneuver, and you got to be very aware of that. And I think in the past, people have not been so aware of that, and it's led to some really problematic things dealing with cosmology. I'm going to give you two examples of the past where this led to problems. Number one, we have this thing in Genesis creation account there in verses 7, 8, 14, 15, 17, and 20. The Hebrew word is rakia. And this is something that God made on day 2. And I'm going to talk more about this in my later presentation, not this first one. And its purpose on day 2 is to separate waters above from waters below. And God called it heaven, it says in verse 8 of Genesis 1. And the Septuagint, that's the abbreviated by the Roman numerals for 50, LXX. They translated the Hebrew Old Testament into Greek around 3rd century or so BC. When they got to this word rakia, they translated it as stereoma, which I believe what they were trying to do there, they were trying to interpret, or in this case, translate the Bible, the Old Testament, in terms of the cosmology. They said, aha, God made this thing on day 2. He later on day 4 put the stars there. And we know by our cosmology that this is a hard crystalline thing. So let's just call it that. And this became the translation of the Septuagint. And that was the Bible that many Christians in the early Christian era read. People were reading Greek at the time. A little later on, around the 4th, 5th century, in the West at least, the Greek had fallen away and Latin had become the common language. And so Jerome translated the Old Testament and now the New Testament from that Greek into Latin. He also knew some Hebrew, so that helped him out quite a bit, working from some of the Hebrew manuscripts he probably had. And he chose the word, the Greek or the Latin word firmamentum for this. And if you know English, you look at the first four letters, you see the word firm. And it turns out this is a very good translation, I think, of the word stereoma into Latin. Unfortunately, it's a terrible translation of the Hebrew word rakia, as it turns out. And what Jerome was doing was, again, endorsing this idea of a hard crystalline sphere centered around the Earth. And about 700 years ago, you had the first English translation of the Old Testament, and John Wycliffe did this. And when he didn't know Hebrew, he worked from the Vulgate, and he worked from the Greek even. And so he took that Latin Bible, and when he got to firmamentum, he didn't know what to do with that exactly. And so what he did is he simply transliterated it into English and created a new word. And that word is firmament. And for the next few hundred years, that is how this Hebrew word rakia was translated. And again, I'll talk more about that later. I think it's a bad translation. Modern translations done in the last 100 years or so generally have translated expanse, and there's a good reason for that. That's what the word means. So it's a much better sort of translation. And this has caused problems because when I was coming down growing up a half century ago, I was felt called to be an astronomer for God's glory and to share creation like I am this evening in terms of scripture. And when I looked at I started reading the Genesis creation accounts, I thought, well, if I'm going to be a creation scientist, I need to know what I'm talking about. So I started reading it, paying very careful attention to the astronomy. And right away, in the first 6-8 verses, I ran across this thing called the firmament, and I didn't know what that was. And nobody around me could help me with that. And I was really limited on resources, but a lot more resources available today than ever was back then. So it kind of held me back for many, many years. And so it's caused people to think about this rakia that God made on day 2 completely wrong, I think. It caused me to think about it wrongly for a very long time. And notice the root of the problem was that there was an attempt to accommodate the latest cosmology of the day. And that's the temptation I talked about earlier. People think that our science today has given us the truth, the ultimate reality. And so we better understand scripture in terms of that. Well, as it turns out, nobody believes that ultimate reality that the ancient Greeks had anymore. So that caused a problem because when your paradigm shift occurs, when people no longer accept the old science, but now a new science, what does that do to scripture when you've interpreted so many years in terms of that old science? And it caused a lot of consternation, a lot of confusion for me. Here's a typical illustration of this. This is supposedly, it's called the Flumerian Engraving. It's supposed to be a medieval representation of what the world was like. You've got a flat earth, first of all, which is nonsense, but that's what most people seem to think. Everybody thought in the Middle Ages, not true. And you've got that dome sitting there with the stars and the moon and the sun in it. And this intrepid explorer has ventured to the edge of the flat earth, found a hole and stuck his head through it. He's looking through this little portal to the inner workings of what's going on. Well, again, this is claimed to be medieval, but actually it didn't start appearing until 1888 in a book by a man named Flumerian. It's a Frenchman wrote this book. So this is actually not an ancient representation at all. It's a late 19th century representation of a misunderstanding of a lot of church history and cosmology. So we're still living with this very poor translation of the rakia that goes back now 2,400 years. Now, another attempt to explain cosmology goes back to a guy named Claudius Ptolemy. In the 2nd century AD, he worked out a model to explain planetary motion. The stars all remain relatively fixed with respect to one another. They change throughout the night due to our rotation, and they change seasonally throughout the year due to our orbit around the sun. But the stars come back and cycle again. The stars of winter are starting to disappear for us. They'll be back again in another year, but they're going to stay around for a little while longer. But the planets are different, and the sun and the moon are different. There are 5 naked eye planets. They look like bright stars to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. And the moon takes about a month to move through the stars on a path that it follows. And the sun takes about a year. And the planets take various lengths of time. And the motions of the planets be kind of complicated. The sun and moon go from west to east with respect to the stars, but the planets, they move forward for a while, then they move backwards for a while, then they move forward again. And this really defied explanation for a long time. And what's happening is when they go backwards, we're passing these planets up on the outer planets as we pass them imagine passing a car on a highway. If you're driving along and you're going faster than another car, then as you pass that car, it looks like that car is going backwards. And it's not, of course, it's just from your perspective. So when we lap a planet on an inner orbit, it makes it look like it's going backwards. This is all explained in terms of what we call the heliocentric model, where the planet, the Earth is just one of several planets orbiting around the sun. But you see, back a couple thousand years ago, people were geocentrists. They believed the Earth was the center. So how do you explain this motion? Well, Ptolemy came up with this idea. He had each of the planets, the 5 naked eye planets, plus the moon and the sun to a certain extent, they moved in circles on a small circle called an epicycle. And that epicycle in turn turned on a much larger circle called a deferent. And what we had to do is just adjust the sizes of those two circles and the speeds of those two motion, and he could explain the backward motion, what we call retrograde motion. Here's an example. You have the Earth at the center, and that little red dot represents Mars. And Mars is going in a circle, as you can see on that smaller epicycle. And that epicycle in turn is going around the Earth on that larger circle. In the center of that motion is a little white dot you can see moving along there. Now, if you combine those two motions together, the motion of Mars as seen from the Earth is rather complicated. There's a white line that runs from Earth to Mars. And as it does, on the far right, you'll see 5 asterisks that represent stars. And you'll see that Mars will appear to move forward, that is from bottom to top, but then periodically it will stop and move backwards. Right there, it's going to move backwards right now, and then it moves forward again like that. And just by adjusting the sizes and the speeds of those two motion, he could replicate this. And this model was just fantastic. In terms of longevity, it was the most successful theory in the history of science. It lasted 15 centuries. I don't know of any other theory that's lasted as well as that one has. And it was considered truth and still being taught as truth as recently as 4 centuries ago. But 400 years ago, that all changed. Here's the strength the model had. From time to time, there would be slight discrepancies between the predictions of the theory and reality. And the way you could fix it would be to add a few more epicycles. You start off with about 12 or 13 original ones in the system. But by the time you got to around 1600, there were now more than 100 epicycles required to match all of this. And so the strength was it could be continually modified, but the weakness was the model was the same. It could be continually modified. You see, a theory that can explain anything and everything doesn't explain much at all because it can't be disproven. Sometimes in science we talk about an idea, it has to at least potentially have the possibility of being falsified or disproven. But if you can't disprove an idea, then is it really science? I think, by the way, evolution has reached that point. No matter what problem comes up, the evolutionists come up with 3 or 4 answers as to why this problem can be explained by evolution. So I think evolution ultimately cannot be falsified. And I think some ideas in astronomy are the same way. And so a model must be capable of being disproved, and the Ptolemaic model really couldn't. And what really did it in 400 years ago was the extreme complexity, which made it difficult for people to accept. We think basically the truth should be simple. That's what really killed the model, the extreme complexity that it had. You've heard of the Galileo Affair, I'm sure, 400 years ago. Most people are very ill-informed about the Galileo Affair. I tell people many times, most of what you think you know about the Galileo Affair is not true. For instance, it's usually portrayed as religion getting involved in an area where it had no business. It was conflict, religion sticking its nose where science should be ruling and not the other way around. Well, it turns out it was not that at all. It was a real competition between 2 different scientific models. It's a long story. I don't have time to talk about it tonight, but suffice it to say that there was a lot more going on there, and it really wasn't religion versus science at all. It was science versus science. Well, with those 2 lessons, by the way, we're still paying the price of of that today, because we creationists are always having this Galileo affair thrown up at our faces. They're saying, well, you people, you creationists are just like the Roman Catholic Church 400 years ago, trying to impose the Bible and religion and Christianity on top of science, and that it wasn't it at all. Well, with those two warnings, the Ptolemaic model, and before that, and in conjunction with that, the celestial sphere model, that hard crystalline sphere, and the disastrous results it had in both cases, I think even today there are many Christians who want to wed the cosmology of today to the Bible. What I'm talking about is the Big Bang. It became the dominant cosmology about a half century ago. It was a big event that happened in the 1965. I use the word cosmogony there. Technically, that's what the Big Bang is. Cosmogony is a study of the history and origin of the universe. The cosmology is just a study of the structure of the universe. Unfortunately, almost nobody makes that distinction anymore. They're so blurred in most people's minds. Now, there are many Christians out there who claim to see Genesis creation in the Big Bang. They say, in the beginning, with the Big Bang, God created the heavens and the earth. I'm not being flippant about that. There are some people who actually say that, but the idea is that the Bible teaches the Big Bang from the very beginning. It's amazing to me that nobody seemed to see that until after pretty secular scientists discovered that sort of idea. And many people want to use that as an evangelistic tool. They say, look, if the world had a beginning, then there had to be a beginner, that is a creator. Let me introduce you to the creator. So they really mean well. It's really an appealing argument in many respects. However, in order for this to work, I have to ask two questions. Number one, is it true? You see, you can't build the truth of the gospel on top of a lie. That's, it's an improper foundation. So is the theory true? And I think there are serious questions about it being true. And second of all, is it biblical? And I definitely don't believe it's biblical. So I think this approach, using the Big Bang as your evangelistic tool and your apologetic for Scripture, I think is flawed on two counts. It's bad science, and it's also not biblically solid either. Now, this is a very famous man. If you don't know you don't recognize him, you'll certainly recognize his name. It's Edwin Hubble, and he was a very prominent astronomer in the first part of the 20th century, and he made several good contributions to astronomy. For instance, in 1924, he proved that there are other galaxies. Up to that point, the dominant idea for half a century was that the Milky Way galaxy, which is collection of a few hundred billion stars, of which the sun is just one of the stars. The belief was by astronomers at Hubble's day, 100 years ago, was that the Milky Way was all there was. The universe, the Milky Way, the galaxy, all the same thing. And in 1924, he showed that no, there are many other galaxies similar in shape and size to our own Milky Way. And that was a revolutionary idea. It made the universe much bigger than anybody had imagined prior to that. And he followed that up in 1928 by another study where he said the universe is expanding. What he means is that galaxies are getting farther and farther and farther apart. Oh, well, there's data to support that. Now, its interpretation, it's expanding. What we call the Hubble relation is underlying that, but I'm not going to talk about that fine point right now. And that sort of began modern cosmology. Modern cosmology, as we know, it's been around for about a century. This is a photograph of the 100-inch telescope at Mount Wilson that Hubble used for most of his work. And here's a photograph of the Andromeda Galaxy. This is a very important piece of sort of astronomy, one galaxy that became very important in this whole development of the story. The Andromeda Galaxy is the closest galaxy of any size to our own Milky Way. It contains a couple hundred billion stars. It's about 100,000 light years across. The sun, our own galaxy, looks a lot like this probably from the outside. We can't get outside to look at it like this one. But if this were our own Milky Way, the sun would be about halfway out from the center to the edge somewhere. And by the way, this galaxy is a little over 2 million light years away from us. However, you can see it in a dark sky with the naked eye. I've seen it many times in our autumn in the Northern Hemisphere. It's a pretty easy object for me to pick out if I'm in a very dark sky. In the city, I can't do it, but certainly out of town with no lights and no bright moon, I can make it out. This is another galaxy. This is called the Sombrero Galaxy M104, and it's about 30 to 50 million light years away, quite a bit farther away than than the Andromeda Galaxy. This is what we call a barred spiral galaxy. I love barred spirals. I think they're beautiful galaxies. These are spiral galaxies I'm showing here. I just think spirals are really cool looking galaxies. But Hubble found that the farther away these things are from us, the faster they're moving away from us. Most galaxies are moving away from us. The Andromeda Galaxy is one exception. It's nearby, but with any kind of distance, galaxies are always moving away from us, and they're doing so with ever increasing speed with increasing distances. That's how we know, or we believe, the universe is expanding. Now, this is an actual publication paper from 1928 from Hubble's groundbreaking study. What he did is he took measurements of distances of galaxies, all best he could at the time, and he plotted those horizontally. That's the parsecs you see there, P-A-R-S-E-C-S. That's a unit of a distance. So you have 1 million parsecs there, and then 2 million parsecs. Parsecs about 3¼ light years. And then he measured the velocity of recession, and that's plotted vertically. You got 0 and 500 and 1,000. And if you look carefully at this, you can see the data tend to go from lower left to upper right. That's what we call a linear relationship. There's some scatter there, but that's okay. And Hubble drew through the data 2 different lines, and that's showing helping your eye to see this relationship. Again, with increasing distance, the velocity is greater and greater. Now, it didn't stop with this. This was done 97 years ago now. And this was just the first publication. People over the years have expanded this tremendously. Now we have millions of galaxies involved in these studies, and it's a very tight linear relationship. So it's very well founded. Hubble the first to really show this nearly a century ago. That's the basis of the expanding universe. Now, right away, different people begin to ask the question, what does this mean? You see, part of the problem was that since the ancient Greeks, people in the West, for the most part, thought the universe was eternal. That's always mystified me, because the West has been influenced by Christianity so much, yet they kept this ancient pagan idea in the West that the universe had always been around. Maybe the Earth hadn't always been here, but the universe had been. And I guess my question for those people over the past 2,000 years in Christian circles, scientists who were Christians too, what part of in the beginning God created did you understand? Well, this is a man almost as well known as Hubble, at least among scientific circles. Yeah, his name is George Lemaitre. You can see the collar there. He was a Belgian priest, but he also was a theoretical physicist. Many people are surprised to learn that, but there are many Catholic universities here in the United States. There are some around the world, and many of the professors there are priests. So they have to go off and get graduate degrees in various fields. So he's a theoretical physicist, and he came up with this idea, what he called the primeval atom, or the cosmic egg. He said, look, if the universe is expanding, if we ran this backwards into the past, then wouldn't everything have started at one place at one point in time in the finite past? That's why it's kind of an egg that hatched, or an atom that gave birth to the rest of the universe. So the idea was that the universe began in a very dense, very hot state, sometime in the finite past. The universe is not eternal, and begins to expand rapidly, and expands to what we see today. Now, so again, I just stated that ultra dense, ultra hot state. The universe began today, they'd say 13.8 billion years ago, and the universe has expanded and cooled into what we see today. Now, this met a lot of early rejection. One reason was it just went counter to 2,000 years of thinking. If you've been thinking a certain way for a very long time, it's very hard to get out of that thinking. As we refer to this thinking outside the box. So this is very much inside the box thinking that the universe is eternal. Well, outside the box, you're going to say, well, maybe the universe had a beginning in the past. And again, a Christian should have realized that, because, well, that's what the Bible starts with, creation in the past. So the universe did have a beginning, and that's one essential element that's similar to the creation account of Genesis. That's a starting point for a lot of people who want to argue this Big Bang apologetic, because they think that somehow this proves God. And there was it's kind of a sluggish, slow warming up to this idea. But by 1965, that all changed with what we just call this discovery of the CMB. That is short for cosmic microwave background. Cosmic microwave background, the CMB. What is this? Well, the universe was very hot in the past, according to the Big Bang model, and there should be like a relic radiation field coming from that very hot, dense matter in the early universe, traveling over billions of light years to get here. It would have cooled tremendously because of the expansion of the universe. It would have cooled by about a factor of 1,000. So instead of being about 3,000 Kelvin in temperature, it ends up being about 3 Kelvin, which is really, really cold. It's almost absolute zero. But it's in the microwave part of the spectrum. We can't see with our eyes, but by the early 1960s, we had ability to detect these things. The technology had improved to the point that it could be done. And here is a plot of some of the early data of this. It shows a background radiation coming from all directions in space. And you'll see that it's got a hump on the curve there. It's lower frequencies to the left, higher frequencies to the right. Intensity increases upward. It rises rather slowly with increasing frequency, then it drops off rather steeply. We call that a black body curve, and that's a very smooth fit. The little dots you see there actually is the 2.726 Kelvin black body, and those other little symbols are different experiments, and you can see the match is very good. And this is coming from every direction in space, and so the universe is filled with this radiation background, and the eternal universe models could not explain this. But the Big Bang model predicted it. It should exist. They couldn't get the temperature right, but you wouldn't know that beforehand anyway. So that is the big evidence of the Big Bang model today. Now, there are several problems with it. I'll go over one real quickly with you here. The COBE experiment, that's a Cosmic Background Explorer, was launched in 1989, and its job was to look for small temperature variations. You see that background temperature is not exactly the same in every direction. They thought it ought to vary by 1 part in 10,000. You only got 3 Kelvin, and you're going to vary by 1 part in 10,000. That's not very much. But they had detectors available 30 years ago that could do this. They put them aboard a spacecraft to get above the Earth's atmosphere where you need to be to get this precise measurement. And they found that the predictions failed. The fluctuations in the background amounted to 1 part in 100,000, off by a factor of 10. And that's pretty lousy in science to be off that much. These fluctuations are required for structure in the universe. If you don't have little slightly warmer and cooler or dense, less dense regions in the early universe, then you don't get structure like galaxies and clusters of galaxies. It's a very fine tuning sort of thing has to be there. So they found that the fluctuations were an order of magnitude lower than it predicted. That's a factor of 10 when we say order of magnitude. But so how they fixed this? Well, they adjusted the model to fit the data. That's not the way we're supposed to do science. You know, I come up with a theory to explain something, and you go out and make a prediction, and you go out and do the test, and you find out it flunks terribly. So what I do is I go back into the office, I go back into my study, and I refigure the model, the theory, to make it fit the data. And then I say, oh, see, this proves my theory. Well, no, what you've done is you've constrained your theory, but you've not proven your theory. Again, that's not the way science works, but they get away with this. I really get upset when I sometimes hear scientists or other people say, the data beautifully matched the predictions. And I'm saying, no, it didn't. I was around 30 years ago. I know that it didn't match, and you had to change the theory to fit that. And this is a map of the background radiation out there. You've got those lighter and darker regions that are showing up there. The lighter regions, the reds and the yellows, are hotter than normal average regions. The blue and the dark blue are cooler regions. And there are a couple of areas in here of interest. There's a long bar over here, a yellow bar over here in the lower left. I'm trying to indicate with a pointer. I hope you can see that, but there's a long bar, a ridge, and the lower right of the diagram. Let me explain first. Let me back up a second. What you're looking at here. Imagine if you wanted to do a map of the world, you have to worry about distortions when you try to take a surface of a sphere and put it onto a flat map. So one way you might do that is you'd flatten it out so that you've got the equator running horizontally across this oval kind of shape. The equator runs horizontally, and at the top and at the bottom are the 2 poles. So imagine this being like a a map of the world shown like this. Well, this is a map of the sky. Instead of looking down on the earth, you're looking up into the sky. You've got this long thing over here, long ridge of bright yellow and green on the lower right. That's called the axis of evil. Nobody knows what it is. There's a region down here that's very dark blue below that. That's called the Great Cold Spot, and nobody knows what that is either. Okay, other problems. Well, it's called the horizon problem. I don't have a lot of time to talk about that this evening. A horizon problem comes from the fact that we can look off in every direction in space and see about the same temperature to 1 part in 100,000. That's pretty precise. But why is it? Why is it the same temperature? Because those disparate parts of the universe have never been in thermal contact with each other so that they can exchange heat and come to the same temperature. It'd be like if you had one person heated up something in an oven and another person heated something else up in an oven, and they didn't communicate with each other, and then they got together and they compared the temperatures of their two ovens, and they found out that they're the same temperature to 1 part in 100,000. Well, I think you would find it hard to believe that would happen. There would have to be some sort of communication between the two in order to synchronize their temperatures so well. That's what the universe is like. The temperature is the same everywhere. It seems like with 1 part in 100,000. How can that be? Then you have what's called the flatness problem. It has to do with geometry of the universe. There are a couple of ways you can look at it. I like to look at it in terms of the ratio of the kinetic and kinetic and gravitational potential energies in the universe. That gives you this ratio we call omega. And omega, the value of it is either less than 1 or greater than 1. Now, if the universe starts off less than 1, then as the universe expands, it becomes less and less and less and less. After billions of years, it ought to be 0 by now, to a very high degree of precision. And if it's greater than 1 initially, then it should increase to 2, and then to 20, and then 100, and then 1,000. It goes the other direction. So in the universe, it's billions of years old, been expanding for billions of years. The value of omega should be nowhere near 0, near 1. Yet it is. The best we can measure it, it appears to be equal to 1. And why is that? That doesn't make any sense. And those are big problems that developed in the 1970s. Now, they solved this in one fell swoop in the 1980s, a thing called cosmic inflation. This idea that the universe was, when it was very small, we're talking like a billionth of a second after the Big Bang, the universe underwent a very brief but very rapid expansion phase. It was expanding much faster than the speed of light. And that expansion didn't last very long, but it really stretched the universe out big, and then it went back to normal expansion like we have today. And this in one fell swoop answers those two problems, and maybe a third one. The problem is there's no evidence for this. There's absolutely no evidence for this at all. They simply made it up to fix the problems. And there's a Latin term for that. It's called ad hoc, making these things up. And on top of that, sometimes we say it's special pleading. You know, you're giving me something here to help me out here, but there's no evidence for it. That's not the way science works. Science is supposed to be based on evidence. There is no evidence for inflation. They keep looking for it, but they haven't found it, and I don't think they will, because I don't think it ever happened. I have to question, is this science? This isn't the way science is done. And it's because it's not falsifiable. It's one of those aspects of the Big Bang Theory that you can't falsify it, because you're always allowed to make up stuff, ad hoc, special pleadings in order to make it work. And this has been done repeatedly over the past half century, making up things to try to salvage the model. More problems. We have in electricity and magnetism. We have electric monopoles. We have positive charges and negative charges. Magnets don't come that way. You have a north and south pole, but they always come together. That's the way the theory should be. But turns out in particle physics, there's a possibility of what we call magnetic monopoles. And in fact, in the Big Bang model, there should have been some monopoles created in the early universe. We've never seen any. There have been numerous experiments looking for them, going on for more than 30 years, looking for magnetic monopoles. If they ever found a magnetic monopole, they'd say instantly, they'd say, this is proof of the Big Bang model. Of course, as long as they're not finding it, they won't tell you that. That's the way it generally works. They won't tell you about the problems that they have in their model until after they've found a solution for it. So they keep looking for monopoles, magnetic monopoles, because without that, the Big Bang model is dead. And then there's this asymmetry between matter and antimatter. Now, matter is the normal stuff we see around the world around us. Things are made of protons, neutrons, and electrons. You may have heard about antimatter in sci-fi stories, such as Star Trek. They used matter-antimatter conversion to power the ship and run the engines on the ship. Well, it turns out antimatter is not science fiction at all. It actually was predicted in 1930 and confirmed a few years later. Whenever matter and antimatter come together, like a proton meets an antiproton, there's an explosive release of energy as they annihilate each other. That's how we know the universe is dominated by matter. If there was any significant antimatter out there, then someplace, somewhere, sometime, the matter and antimatter regions would touch, and it would be this blazingly bright eruption of energy going across huge parts of the universe. Never been seen. We're very confident the universe is made of matter. There's an asymmetry. There's no symmetry between them. Here's the kicker, though. The Big Bang model requires that there be an absolute symmetry. There be as much matter as there is antimatter. There is no explanation as to why there's this asymmetry there. I mentioned the axis of evil, that long, about a 60-degree swath in the sky, which is normal than average. By the way, that axis of evil coincides with the Earth's orbit around the sun, same plane of the Earth's orbit around the sun. Why is that? Again, no explanation. The great cold spot, really much colder than it should be. It's a huge structure the size of the universe. No explanation for that. Here's a much more recent diagram of the CMB. You can see over here that long ridge in the lower right. It's kind of a dark red and kind of brown on the lower right. That's the ridge of what we call the axis of evil. And down here is the great cold spot. And again, neither one gets talked about much, at least not with popular press accounts, because there's no explanation for it in the Big Bang model. Now, the changes of the Big Bang model have occurred over the years, many, many changes. The expansion rate has changed. Used to be for much, first 1960 to 1990, it was 50 kilometers per second per megaparsec. Now it's known to be probably around 75 to 80 or so, 75 kilometers per second per megaparsec. This has a very strong effect upon the age. Back until 30 years ago, and for 20 years or more, people have been telling us that the universe was 16 to 18 billion years old. But in the early 90s, they decided, whoops, it's not that at all. It's 13.8 billion years. Actually, they said 13.7, and they changed it to 13.8 just a few years later. So they keep changing that, and that's driven by changing expansion rate. By the way, notice that they were very sure of that date when they said 16 to 18 billion years. Now they're saying 13.8 billion years plus or minus 1%. So those two ranges of dates do not overlap. Dark matter, I never talked about that, and I'm not going to right now. But dark matter consists of 90% of the universe. By the way, I think dark matter is real. I think it exists. I think it's fantastic stuff. And we don't know what it is, though. But, you know, cosmological models until about 30 years ago didn't include dark matter at all. Now you wouldn't think of not including it. In fact, models don't work without dark matter. Well, what happened 40 years ago when you did the Big Bang cosmology? Well, dark matter wasn't there, but you didn't think you needed it back then. The cosmological constant's been introduced. It's now called dark energy. This is a repulsion that the universe has for itself, causing the expansion of the universe to increase. And again, that was not introduced again until 1998, 1999, it's a little over 20 years ago that concept came along. And yet, you think the cosmology can't get along without it, but before they thought so. So the model has changed again and again and again and again. Any new data comes along that causes the problem, we'll just simply make up a new effect to see if it works. So I compare to what it was 30 years ago, the Big Bang model. The expansion rate was different. There was no inflation. Well, it was just beginning to be introduced at that point. There was no dark matter involved. There was no dark energy involved. There was no string theory. I haven't mentioned that either, but now you put string theory in. And back 30 years ago, there was complete confidence in the theory. I remember back in the 80s, early 90s, if you went around and asked astronomers or cosmologists or physicists about the Big Bang model, they'd say, oh yes, what we're telling you here is true. There's no way of getting around it. And of course, today, the story has completely changed. The model has completely changed. the confidence hasn't changed at all, though. The confidence is still there, even though they had confidence in a totally different model a few years ago. What would the this thing is starting to look like epicycles to me. Remember, the problem is when the Ptolemaic model got into trouble, when it didn't match, its predictions didn't match reality, the solution was always to throw in another epicycle. And that big edifice of complicated cycles on cycles and little gears and wheels put in looks so complicated that people begin to realize, well, there's something amiss here. This model cannot work. And so we must look for something simpler than that. Now, how does this compare to Scripture? Well, Scripture doesn't change. Our understanding may change in Scripture, but Scripture itself does not change. Which one do you want to place your eternal destiny in? Something that changes or something that doesn't change? The origin of the universe. Some people see God behind it. They look at the Big Bang and say, well, what caused the Big Bang to happen? Well, it must have been God. And those are the Christians who are trying to use this as an evangelistic tool. But other people see a quantum fluctuation. This is a misapplication, I think, of quantum mechanics, but they see little variations that take place. You can have violations of conservation of energy over a very short length of time under quantum mechanics, this interpretation, at least of quantum mechanics. Again, I reject this, but that's a common enough interpretation. And they say if the universe has zero energy, then the universe could exist forever because, well, it has zero energy, so that violation is trivial and it could last forever. The universe just pops into existence, and because its energy is zero, it doesn't really violate anything. Well, I look around and I see a lot of energy out there. And how in the world do you get the energy to be negative? Well, you have to invoke a lot of negative forms of energy out there that cancel out the book somehow. Now, no one's ever been able to prove that. In fact, trying to come up with negative energy to balance the books has turned out to be an impossible task, I do believe. And yet people are willing to risk their eternal destinies upon the possibility that the universe might have zero energy, despite all this evidence to the contrary. That's not rational. That's not rational at all. I got these two quotes from famous scientists in the last 40 years or so about quantum fluctuations. One of them is this: the universe is the ultimate free lunch. We're told that there's no such thing as a free lunch. I don't know how well this works in Chinese, but in America, in English, we sometimes say there's no free lunch, which means if somebody is offering you a free lunch, someone's paying for it, and maybe they're expecting something from you. The other one's even better. This statement is the universe is just one of those things that happens from time to time. And this is really the ultimate evolutionary theory. You know, they like to say that the origin of life was just a mere accident. The earth itself being conducive for life, that was a mere accident. And the evolution of life that led up to me and you, to humanity, that was a mere accident. We're just a series of long improbable accidents that led to us. But the accidents didn't start with life. It didn't start with the earth. It started with the universe itself. The universe is just one of those accidents that happen. So we have an accidental universe leading to accidental humanity, accidental me and you. That is very contrary to the biblical worldview, which brings my next point. Is the Big Bang biblical? The event happened 13.8 billion years ago, yet creation we know was, for Exodus 20:11, was in 6 days, and the was not that very long because the chronologies we have in Scripture. We have in the evolutionary model, coming out of the Big Bang, many stars preceding the Earth. In fact, there were stars for 9 billion years before the Earth came on the scene. Yet, according to the creation account of Genesis 1, the Earth came first. You can't have billions of years of stars before the Earth and be faithful to Scripture. Also, the evolution of the universe, the Big Bang, is an ongoing process, but we know that ended. God stopped the creation process and rested on the seventh day. But you would have to have this keep going on and on and on because this creation is continuing even today. And where do you place the time? Well, you know, I'm open to the possibility of, you know, long periods of time, millions of billions of years. Be very careful. Listen to what I'm saying here. I'm open to that possibility. However, it has to be done in a biblically faithful fashion. And over the years, I've heard all sorts of explanations of day, age, and allegory, all sorts of ways to try to do this. But all of them shortchange Scripture. no one can give me an example of how you can explain billions of years and still be faithful to Scripture. So I'm sorry, but the Big Bang misses on that point too. Problems with the Big Bang and the Bible saying you're apologetic, and that we got to realize that the direction of research in this field is very atheistic. It's led by atheists. It's not. I can't see a single theist in the bunch, let alone creationist or Christian, leading the fight here, leading the study of this whole thing. The time issue is broad, is bad. The order of creation is wrong. I mentioned the stars coming before the earth and so forth. And the beginning of the universe and the end of the universe are sudden. We know from 2 Peter 3 and other passages that the universe will come to an abrupt end rather suddenly. Well, I think it's like bookends. If the universe began suddenly, I think it ended suddenly. I think it's because it began suddenly too. It makes no sense to me to have it begin to go gradually and unfold over billions of years, only to have it end rather abruptly. And Scripture could not be more clear on that. 2 Peter 3:10 again. And this is a very important point I'd like to leave you with. When the Big Bang Theory is abandoned, if you wedded your understanding of Scripture, that warning I gave at the very beginning, the Big Bang is how God created the universe. If you make that your apologetic, you make that interpretation of Genesis and the rest of Scripture, then what happens to your apologetic when the Big Bang model is discarded? And I'm confident it will be, because the history of science has that way. You have an idea that comes along, it's widely accepted, and eventually it's discarded. So if you interpret the Bible in terms of the Big Bang, it's going to be just like when they interpret the Bible in terms of the Ptolemaic model when it went away as a serious model, and also this idea of this hard sphere to which the stars were attached. Again, it was a bad thing when people went that way and wanted to interpret Scripture that way. So we need to be very careful and learn the lessons of the past. So it's always changing. This Big Bang model, it's also contrary to Scripture. And again, when it's discarded, what happens to our apologetic? Well, I thank you very much. I guess it's time for a break. I'm looking forward to speaking to you once again in a little bit.